All right, so I wanted to go over some hints for the circular motion worksheet, which I didn't give you any answers on this. This is just all hints. Here's a question. How do we put revolutions into radians, right? Well, one revolution is 2 pi radians, so they're equal. So on any of these where they talk about um, like the Earth rotating once, um, so what is that in radians? Well, it's one revolution. So the delta angle will be 2 pi, right? Because that's equal to one revolution. Um, yeah, so then you just need to do that. And you could also use you can also use these calculators. Did I put a link? Oh, I didn't. There's some calculators in the book, and I'll put a link up there. You just click on them, and it'll take you to the book. And for the first couple problems, it's angular velocity. And you can use this calculator to input your numbers, and you'll get the angular velocity. You could also change it if you want to solve for a change in time or a change in angle. So you can use that, or you can use Desmos, whatever you like. So these are the conversion factors. This is supposed to say from right here. This actually says from degrees from radians to degrees. So this is a dimensional analysis where you want to go from degrees. If they give you degrees and you want to get to radians, this is from degrees to radians. So you put the whatever number they gave you here, whatever x in degrees, and then you divide by degrees, and this will equal some type of radian. Um, Sometimes they say that radians, instead of saying radians all the time, they say rads, rads. Um, I think they write it as rad, but it's pronounced radians, right? So then they're kind of like newtons and n. So then if you want to go from radians to degrees, you just flip the conversion factor. So radians will go on the bottom, and degrees will go on top, and this will equal some type of degree. Right, so that's conversions. So I kind of set up number one for you here. What is the wheel's angular velocity if it rotates through 720 degrees every 2 seconds? Okay, so they gave it to us in degrees, but we need it in radians. So we have to convert the 720 degrees into radians. So I set this up for you to go from degrees to radians, just like we have here, degrees to radians. We divide by 180 and multiply by pi. And you'll get the delta degree, right? So all you need left, once you have that, you'll just put that in there, and then you divide by delta t, which is right there. So that's all you need to do. And then whatever you get, you'll put it in a square, right? Make sure you highlight your answer. So that's how you do the first one. I would like it if you use the guess method. Write down what's given. They gave us 720 degrees, but we need to convert it. They gave us 2 seconds. What's the unknown? They don't know what W is. Then you substitute, put in your numbers, and then you solve it, right? So that's how you get through the whole problem. And I'm going to put this video up when we're done with the Zoom, so it'll be up after this class. What is a wheel's angular velocity if the wheel rotates a quarter turn every second? So if you have one full turn, it's 360 degrees, right? So what's a quarter? It's 1/4. So how many degrees is a fourth of 360? Then you got to put it in radians, right? So get your degrees and then put it in radians. And then it's the same as the last one. Delta, the number of angles in radians divided by how much time. If a wheel rotates at an angular velocity, oh, here they gave you, see, I started to guess. This is actually supposed to be, I kind of took a bad picture. G. So G, what's the unknown? If a wheel rotates at an angular velocity of 3 radians per second, what angle? Oh, they want to know what is the angle. So what equation are you going to use? We're going to use, let's see, what is the equation? Angular velocity equals delta angle over delta t. So we know W, right? We know T, so we just need that. So delta angle is equal to angular velocity times the time, right? So just multiply those two. I get a little multiplication times delta t, right? So this is the formula you're going to use. The delta angle is equal to, or the change in angle is equal to the angular velocity times the change in time. Change in time is just 5 seconds. So it's just multiplication. Remember, again, once you get your answer, once you substitute, put your answer in a box. Let's see, the Earth rotates once. Okay, so it's rotating once. So how much revolutions is that? That's one revolution. What is that in radians? Again, that's up here, right? One revolution is 2 pi radians. So you got the delta angle because you need it in radians, right? And then you got 24 hours. Now you just need to convert that. How do you convert hours into seconds? You have to do this, hours into seconds. You use this. But this was to convert from days to seconds. So hours to seconds. I think that was on the notes too. It's also on the notes if you forgot. So make sure you know how to convert. You could also Google it, right? Change 24 hours into seconds. You could say in Google, how many seconds in 24 hours? And that'll get you an answer. It's better to know how to do dimensional analysis though, right? So a quick little review. If you want to go from 24 hours, 1 hour equals 60 minutes. So the hours cancel. 1 minute has 60 seconds. So now our answer is in seconds. So you'd multiply across and divide by 1, and your answer will be in seconds. So you'll get some answer in seconds. That'll be your delta t. So delta t, the change in time. Yeah, so we know that, right? There's 24 hours in 1 day. So how many seconds is that? This will get that to you. What is the angular velocity of the motion? So it's, and again, so here they got the angular velocity of the Earth. What is the angular velocity of the moon? You could probably even look it up in on Google, but I want to see your work. And remember, the best way to show your work, I'll show that in a minute. Now we're dealing with velocity. And you could use this calculator from the book. So if you go to the next page, in the book, there's a calculator here, and you could put in those things. but it has to be in radians per second and meters. So a 10 centimeter radius ball. So we have to change centimeters to meters, like I told you a little earlier on the review of the notes. So remember, you divide by 100, and here again the centimeters cancel, right? Whenever you divide by something the same nature, it goes away. So 10 divided by 100 is 0.10 meters. So this is the R you use. Then we have time. Oh, and this one you have to find velocity first. So step one, find velocity. Velocity is equal to distance divided by time. Then you'll have velocity and R, and you'll be able to use this equation, right? You have R. This will give you the velocity. And then this one, angular velocity equals V over R. So not hard. So with that, I think if you do the notes, make sure you go over the ones from last time, and then you can use these calculators, and then you can watch this video again and go through the problems. And it's pretty much the same process over and over again. What is the angular velocity of an old bone shaker bicycle? What's that? Let's look at that up. Bone shaker bike. So interesting. Bet it was like these. The first true type of bicycle with pedals. Looks like a big tricycle, right? So the reason, why would they want big wheels, right? So you can go faster. Because let's look at that problem. If your radius is large, what is the angular velocity? What was the equation? Angular velocity equals V over R. Oh yeah, so if they want you to find the angular velocity, but if you look at the equation for velocity, and we go through this in the notes, bigger R, bigger radius equals bigger velocity. So they were like, well, if we put big wheels, we'll go really fast. So that's the reason for that design of one big wheel. Yeah, it's interesting. But anyway, so I'm going to put this video up, me going through these problems for you, and I'll put a link to the calculator so you can use those if you like. And that's it.